As forces and displacements are involved in the discussion of solid properties, we know there must also be energies involved, as energy is force times displacement in the direction of the force. When an object is subjected to a force, it generates two properties, stress and strain. Stress is the force divided by the area over which it is applied. If the force exceeds the limit of a material to withstand stress, then the material will break. This value of stress is called the breaking stress. Strain has a similar term associated with it and is most commonly seen when a guitar string breaks or your washing line collapses. The force applied causes the material to stretch. After a certain point, the material will not return to its original shape and so become inelastic. This point is called its elastic limit. After its elastic limit, a material continues to hold the force, but every increase in force leads to a disproportional increase in length up to the point where the material breaks, its breaking point. During all of this extension, an energy has been building up within the material due to the force applied and the extension of that material. This is usually referred to as elastic potential energy, but in the case of purely stretching materials, it is called elastic strain energy. Elastic potential includes squashing energy as well as straining energy. Elastic strain energy is a special case. The equation to calculate elastic strain energy states that the energy is equal to the half the force applied multiplied by the change in the length of the material. It comes from the area under a force extension graph. A force extension curve can be used to show the material's properties of a substance when exposed to forces. As the force goes up, the change in extension of the material is recorded and plotted along the x-axis. When the force extension graph begins to curve over, this tells us that the material is beyond its elastic limit, where force and extension are proportional. Energy is force multiplied by displacement in the direction of the force applied. When you stretch a material, you are applying a force downwards. The extension is the increase in length of a material measured downwards, and so is the displacement of the material. If you multiply the two together, you get the energy. You multiply force and extension together on a force extension graph by calculating the area under the graph. For a simple case, before the material has exceeded its elastic limit, the area under the graph is simply the area of a right-angled triangle, half base times height. So the energy stored in the material under strain up to its elastic limit, the elastic strain energy, is half the change in length multiplied by the force applied, or vice versa.